the introduction to robotics, right? We discussed what robotics is, what a robot is. We mentioned those features that are found in every robot, right? Can we remember them? Can we remember them? Can we remember them? We mentioned, oh yeah, okay, that's beautiful. I'm glad that some of us actually remember. So we mentioned, yeah, lovely. We mentioned um robots should have sensors, robots should have actuators, robots should have intelligence, robots should have a framework, right? And they should be powered, right? They should have some sort of mechanism that generates power to run the robots. Okay, so now we actually also went ahead to talk about virtual robots, and we were able to make our very own first virtual robot, which was a robot that cleaned the ocean reef, right? Used to collect trash underwater. That was a very, very amazing project. Okay, so in today's AI and robotics track, we are going to be making another interesting project. How many of us are excited? How many of us are excited? Beautiful, beautiful. I'm glad. I'm glad. I'm glad that we are excited. Okay, 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 okay. Oh, all right. Okay. So, uh, all right. So for some of you that did the assignment, I think we can present it now before we move further. So I'm very, very happy. I will be very, very excited to see your assignment, to see the assignments that you did. Okay. So I think it's time. So those that were not able to present, probably the screen sharing was blocked from your own end. I think you can try now. Ikechukwu Okoli, can you try again? Okay. Cheesy, you can try sharing your assignments. Let's all look at what you've done. Okay. All right. So I'm still waiting. Who is sharing first? Okay, John. John, you can share your screen. Let's see your assignment. Okay. So while we are waiting for that, I think we can still carry on with our discussion. Okay, so again, if you have your assignments, please. Okay. Jane says she's logging into it. But can't share. Jane, try to see if you can share your assignment now. Try to see if you can share your screen now.
Hello, sir. Can you try checking from your own end if you can turn it on from your own side?
Oh, okay.
Yeah, since you are a host in the meeting, so you can check the control button, the host controls.
Oh, all right.
Yes.
Yeah, it's actually possible from my own end. There is no restriction from my own end. Oh, okay, okay, that's good. All right, so Jane, you can share your screen now. Oh, Jane is saying she can't find her code. What happened? All right, who else is ready? Who else is ready? Cheesy, can you share your assignment now? Let's look at it. While we are waiting for Cheesy, Kamsi, get ready. Ikechukwu, after Kamsi, you are next. Okay.
Oh, wait, hello, can you hear me?
Yeah, I can hear you.
Okay. Um,
All right. I'm still listening. You can carry on. I think I can see your screen now, Cheesy. Okay, okay, that's beautiful. Okay, I can see. All right, the robot is moving. That's beautiful. Oh, interesting.
oh, wait, I think this is the same one as before. Give me a second.
I believe everyone can see Cheesy's screen. I hope we can all see her screen. Okay, okay, that's good.
Oh, that's it.
Oh, okay, okay, lovely. All right. Okay, so the next person, Kamsi, you are next, right? So Kamsi, you can share your screen now. Let's see the assignment. Hello, Kamsi. Jane, did you find your assignment file? Ikechukwu, you can share your screen if you're ready while we wait for Kamsi. Oh, okay. I can see Kamsi's work now. Kamsi, you stopped sharing. I didn't see your work properly. You stopped sharing your screen.
So you did. We all saw it.
Hello, Kamsi. Oh, okay. All right. Please, you can share your screen now. Someone said I've done it. Yes, share your screen, Claire. If you've done, okay, beautiful. Okay, I can see your screen now. Oh, that's lovely. Wow, wow, that's truly amazing. That's truly amazing. Wait, was it your initials that you wrote? Was it your initials? Wow, that's truly amazing. Let's put our hands together for her. She did a great job. Kamsi, I'm also clapping for you. That's amazing. That's amazing. So can I have another person share his or her screen now? I really love what Kamsi has done. I've seen someone else's work, and the person actually also did well. I think she also did well. I think it was Cheesy. Yeah, Cheesy, you did well. Let's also clap for Cheesy, please. Cheesy, you did well. But Cheesy is not clapping for herself. I wonder why. Oh, okay, she's now clapping. Oh, all right. Oh, okay. So, um, all right. So, is there anyone else that wants to share his or her assignment file, that wants to share her work, his or her work, before we continue? Is there anyone?
Yeah.
Anyone? Okay. So, I think we can continue with our work for today. All right. Welcome again, everybody. Oh, okay. I can see Ikechuku's work. Okay. Oh, Ikechuku is sharing. Oh, all right. Let's see. Okay. So once Ikechuku is done, we'll go over to what we have for today. Oh, okay. Okay, KHQ is saying I made 3 different letters on 3 different tabs, but it's only showing the same data. It's fine. It's fine. All right. All right. So, good job. Good job, Ikechukwu. Let's also clap for him. Well done. You did well. You did well. Okay. So, thumbs up to all that did the assignments and got it right. Very happy. That's what it's worth commending. Good job. Good job. Good job. Okay. So, now let's go properly into what we have for today. Okay, now in today's class, we are going to be working with our virtual robots on another interesting project, right? So now we are going to be simulating an environment in which our virtual robot is going to be collecting different kinds of waste materials. All right. So we'll be collecting waste items such as we'll be simulating plastic bottles. Is a simulation. All right. So we have objects representing plastic bottles, and then we have objects representing degradable materials, right? And then we'll have object representing glass materials. Okay, so we'll have our virtual robot going to the various locations in order to collect this. And guess what? It is going to collect it and it will move it safely to the correct location. More like it will take it and place it in the correct spot where it is meant to be. All right. So that's what we are going to be doing. Now, we'll also be looking at ways we can optimize our robots. So what do I mean by optimizing our robots? You see, when programmers work on robotics projects, right, they try to do what is called optimization. So optimization simply means how can we make our robots to perform the same operation using as fewer lines of code as possible. So we'll write our code and then we try to make it effective using few lines. In other words, we are trying to achieve a specific target using few lines of code. All right. So that is what we are going to be doing in today's class. Okay. Now we have to open our Vex. So I'm going to share my screen with you right now. Okay, so I'm going to share my screen right now. All right. Can you see my screen? Okay, so I'm currently sharing my screen. All right. I hope you can see my screen, right? Oh, okay. So if you can see my screen, can you give me a thumbs up emoji? Something like this. If you can't see my screen, can you give me a heart emoji? Okay, okay, beautiful. That's lovely. That's lovely. Okay. So I hope my screen is bold. I hope it is clearly visible. I hope. Is it? All right. All right. Beautiful. Beautiful. That's exciting. Okay. So the first thing we are going to be doing is We open our web browser, which is already open here. Now I'm using Microsoft Edge. Okay, so it's totally okay if you are using a different web browser, all right? Whether you're using Chrome or you're using Firefox or you're using whatever, Vex always works perfectly, irrespective of the web browser you choose. Okay, so like we did the other time, we'll go to the search bar and we'll type Vex Code VR. Vex Code VR. Vex Code VR is what you need to search for anytime you want to use the virtual robot for any robotic simulation. Okay, now when it brings up this page, so look for the page that has, look for the link that has Vex Code VR written. Okay, I click this and then it automatically brings me to this environment. Now I'll stop sharing and reshare the new window. Okay. Now, how many of you can see my screen now? Can you still see my screen? All right, beautiful. Okay, that's interesting. All right, so now I'm going to click continue to free and it brings me to my Vex simulation ground. All right. So now we'll be starting by selecting an appropriate playground. So I click select playground and I want to choose this nice Dix mover here. So I click to select Dix mover playground. Now when I do that, this is what I will have. How many of you can see my playground? Okay, that's interesting. Jane can see my playground. Chizzy can see my playground. Okay. Ikechuku can see my playground. All right. Emanuela, beautiful. Okay. So those that are joining us for the very first time, are you able to follow? If you are joining us for the very, I know Emanuela is, I think Emanuela is joining us for the very first time. If you are joining us for the first time, can you raise your hand? You will find the raise hand button. Okay, Emanuela is joining us for the first time. Who else is joining us for the first time? Okay, Baniche is joining us for the first time. All right. Okay, I can see Ayan Feolua. Okay. Do we have any other person joining us for the first time? I can see Sunday. All right. Interesting. Okay. Put down your hands. Can we celebrate those who are joining us for the first time? Can we welcome them? We are glad you are here. You're welcome. You're welcome. Can put your hands together for them. You're welcome. All right. So now we'll proceed. So those that are joining us, all you need to do, you open your web browser, then you search for Vex Code VR, and then you click the link and it will bring you right here. Then proceed to click select playground and choose your disk mover, right? Were you able to do all of that? Were you able to do all of that? Those joining us for the first time, I need to be sure that everyone is following us. Bamiche, were you able to open your Vex Code VR? Hello, Bamiche. Oh, Bamiche is saying that they don't know what it is. Okay. Okay. Also asking where they do that. Okay, so here is just a quick recap. Just a quick recap. In fact, I want to share my entire screen right now. Okay. It's fine. I will just share my entire screen. Okay, I'm currently sharing my entire screen. So here is it. All you need to do is you open your web browser, for example, Google Chrome or Firefox, whatever web browser you choose, right? Then you go to the search bar and you type Vex Code VR, right? You type Vex Code VR. I'm also going to send it to the chat section. Type Vex Code VR in any web browser of your choice, be it Chrome, be it Firefox, be it Edge, be it Safari, whatever, right? It's going to work just perfectly. So when you search for Vex Code VR on a web browser, now it brings you to the window that brings the various results of your search. So scroll till you find this link, the Vex Code VR link, right? Scroll till you find the Vex Code VR link. Now click the link, and when you do so, it's going to bring you to the Vex simulation environment. It will bring you right here. Now, when this pops up, click continue to free. I hope that is clear. So when you've done all of that, simply click, you will find open playground. You'll find open playground, you'll find select playground. So click select playground and make sure you choose Disk Mover. And that way you will be ready to have fun with your virtual robot. I hope it's clear now. Okay, beautiful. Okay, Bamishe, you now understand. Beautiful. So those that are joining us for the first time, do we all understand? Are we all on the same page? Okay, Bamishe asked me to wait, so I'm waiting. Bamishe, I'm waiting. Is anything a problem? Okay, Bamishe is asking, which should I click on when I click on select program? Select playground. So click Disk Mover right here. Disk Mover. Clear now? Okay, Emanuela is saying yes. Okay, I'm glad that Emanuela understood all I've said. Okay, Bamishe, you're raising your hand. Okay, Bamishe understands now. That's beautiful. Okay, so we proceed. I believe we are all on the same page. Now, let's march on. So today's class is going to be super interesting. All right, so let's get to work. Now, with my disk mover selected, okay, so I drag it slightly to the right so that I'll have more room for my code. All right, so the last time we said that robots actually follow specific commands, okay? And what robots do is based on the instruction you give them. All right, so this is where we write our code, right? Basically by joining various blocks of code together in order to tell the robot what to do. And depending on what you've written here, the robot performs a certain action, okay? And the action, of course, it's based on exactly what you have asked it to do. Okay, so now look at our playground. So I'm going to explain this playground, what it represents. All right, now you can see some blue dots, you can see the red ones, you can also see the green ones. Okay, so now the blue dots represents plastic waste materials, which can be plastic bottles, containers, stuffs that are made of plastic, right? Then the red one represents glass, okay, which can be glass bottle, glass containers, and the rest of them. Okay, now the green dot represents biodegradable materials, which can be things like leaves, things like probably um, leftover food and stuffs. Okay, so the green one represents biodegradable materials, red one represents glass, and the blue one represent plastics. All right, so now coming to this area, now the blue square here shows you the correct trash can where the robot has to collect all the green, all the blue plastic materials. All right, so it has to collect all the blue materials and drop them in the blue box. Okay, now for this red square here, this one represents where the robot has to place all the glass materials, right? So what it means is that the red dots have to be moved to the what? Red box, right? Then for this green box over here, this shows you where the robot has to place the biodegradable materials. All right. So the robot has to collect all the green biodegradable materials and place them right in the green refuse box. Okay. So that's the idea. Now, how is the robot going to do that? I hope I'm not too fast. Do you understand? Oh, Sunday, I can see your hand up. Sorry. Okay, Sunday, do you have any question? Sunday, do you have any question? Hello, Sunday, can you hear me? Okay. All right, I guess we should just continue.
Sir,
The-
why is my why do I say meeting host?
sorry, I didn't get that.
My name's on the meeting host. I'm not the host. Just saying.
Your name is the meeting host? Oh, okay. It's fine. Don't worry about that. Just focus on the task, right?
Sir.
Okay. Okay, interesting. All right. Can we proceed now? Okay. The name I address you with are the names I can see on your tile in this meeting. Okay, so let's proceed. Is that okay? All right. So moving forward, now we write the code. Now, when you look at this carefully, when you look at this playground carefully, you will find out that this is basically a grid, right? A grid of cross sections, including vertical lines and horizontal lines. Okay, so that's what this grid, that's what this playground is, right? So in this section, for those that are just joining us, this is where you can change the direction of view of the camera. Okay, so if you click this, you will basically be seeing exactly what your robot is seeing. And by the way, this little guy here within the blue square is your robot. Okay, so while you click this, you will see exactly what the robot sees through the camera. So when you click this, you view from top. When you click this, you view in an other direction. So you have a closer view of your robot. Okay, so that's the idea. So I'll go back to the top view, and then I will move this playground slightly to my right hand side so that I'll have more room for my code. So basically, just like I mentioned in the last class, when using your virtual robots code, typically the first block that should be there is your when started. All right, so you can see when started already here. All right, so if for any reason you can't find when started here, all you need to do is you go to logic and then you scroll down a bit. You should see your when started. Just drag and drop it on the canvas. Okay, now I can't have two when started. I only need one. So what do? I simply delete. There are three ways you can delete a block. One is by dragging and dropping it to this column here on the left hand side where you choose your blocks from. So once you drag and drop, it disappears. Now the second way you can delete is by selecting and then clicking the delete key on your keyboard. It goes away. Now lastly, you can also delete by selecting and clicking the backspace key. It goes off. All right, so whichever method you prefer, can use it to delete your block. Okay, now how do we place blocks here? Okay, now by the way, I am using a mouse. I'm using this mouse right here. So that's what I'm using for my control. If you don't have a mouse, it's totally okay. Your trackpad can also work. So if you want to drag and drop a code, all you need to do is you take your cursor to the particular code you want to drag and drop, the particular block. Then press down the left button of your mouse or trackpad, and then you move gradually to the right. Okay, when you are there, you can now release your hand, and that way you're able to drag and drop a code. Okay, so I'm just explaining for those who were not here the last time. So I don't need this block. I'll simply delete. Okay, now let's continue with the rest of our code. All right, so now I need to show you, remember that you use this block to move the robot. You can use this to move forward, right? This also has a drop down where you click to select reverse. So if you wanted to move forward or reverse, reverse means backwards. Okay, so you can do that. All right, so now let's take a nice look at, I can see someone's hand is up. Okay, Ayodemilade, do you have a question? Any question? Unmute your mic and speak if you have a question. Or you can use the chat section. Okay, it's fine. Let's continue. All right. So now our task is going to be to collect these dots and put them in the right place. So we'll start by collecting the blue dots. And I need to tell you that you can collect only one object at a time. Just one object at a time. So basically, we move the robot, pick the object, move it back and drop. We go again, pick the next one, move it back and drop. All right. So now, when you look at this grid, now the distance between two intersections. What do I mean by intersections? When you look at the grid, you're going to find that there are points where the horizontal lines and the vertical lines cross each other, right? So that point is the point of what? Intersection. Okay. So what am I saying? The distance between any two points of intersection which are close to each other is 200 millimeters. So with that information, we'll be able to know how to move to exactly the right spot in order to locate the material I want to pick without losing it, without moving beyond it, or moving or not reaching its exact position. Okay, I can still see hands up. Is there any question? If you understood all I've said, can you give me a thumbs up emoji? Okay, okay, lovely. All right, Sunday, do you have any question? For Lakemi, do you have any question? All right, so in the absence of questions, we proceed. Any questions? Let's just proceed. It's okay. All right. So now let's get to work. So look at this. The robot is currently here. So I need to move from this point to this point. Now, if I move just 200 millimeters, now I've just dragged my move forward for 200 millimeters and I've snapped it to the when started block. Now, when I do a code like this and click play, you see that the robot will only move from one cross section to the next, all right, because the distance is only 200 millimeters. Okay, now I can click this restart button to start all over again. Now I need to move how many millimeters to get to this dot, to get to this first plastic object, which is the first blue dot. So you can tell me how many millimeters if the distance between two cross sections, intersection of two lines, is 200 millimeters. So how many do I need to move in order to get to this point? 800. Okay, someone is saying 800. Someone is saying 400. Ramishe is saying 800. Sunday is saying 400. Okay, another person is saying 800. 800. Okay. Now, 800 is actually correct. Okay. The cross sections are 200 millimeters. So that means I have to move first 200, another 200, that's 600, right? Look at it. First 200, another 200, that's 400, another 200, that's 600, and the last one, that's 800. Okay, so 800 is in fact correct. All right, but then I need to show you something. Okay, now when we use 800, so if we enter 800 here and then we click play, the robot moves to that point. Okay, Now, look at this. If you look very well, you're going to notice that the robot actually gets to the point of intersection, but then the tip, which is this tiny yellow dot here in front, exceeds the blue dot. The blue dot is somewhere here. All right. So now, as a matter of fact, we have to subtract. We have to subtract a little amount. We have to subtract something from this 800 millimeters. Okay, might not be so little, but we just have to subtract something. Okay, now let me try doing 700 millimeters, and let's see where it will stop. So I restart and click play. It goes and stops right there. You can see that the little blue tip is almost on the dots, right? So the little yellow tip is almost on the dot, and that is what the robot uses to pick up. So when you're saying, I don't understand how the robot moves. Okay, now to move the robot, all you need to do is, when you've written your code, just click the play button, right? That's how it moves. So now look at this. I say drive forward for 700 millimeters, and I make sure it is connected to this when started block. Now let me restart for a while. Now I make sure it is connected. Now I click the play button and it moves. Okay. Now I want to move, instead of 800 millimeters, I want to move 725. So let's do 725. And then when I now restart and click play, it goes exactly to the spot. Exactly to the spot without moving past it. All right. Okay. So having done that, next, if I go to my magnets, I need to energize my magnet to boost. Okay, so I place this right here. So this way, the robot picks up the blue dots, all right, picks up the first plastic object. Now, the next thing I want to do is I want it to turn around. So how do we turn the robot around? Can anyone tell me? How do we turn? We want it to turn all the way around. We want it to turn and face the starting point. How do we turn? Can anyone tell me? Anyone? Beautiful. That's beautiful. That's beautiful. Okay. So now, in order to turn, we simply use turn 180 degrees. All right. So we use turn right 180 degrees. Now I go to drivetrain and I drag and drop turn right. Now I click this to change the degrees. So I type in 180. Now let's see what happens when I restart and click the play button. So it moves straight, then it grabs and turns. Can you see that? Isn't that amazing? Now the next thing we need to do from here is to drive all the way straight back to the starting point. Okay. Now remember, it took 725 millimeters to get to this spot. Now what it means is that it's going to take us another 725 millimeters to go back to the starting point. So what do we mean? We mean we have to put drive forward for 725. So we do 725. All right, and then we hit the play button again. It goes, picks it up, turns, and then it returns to the starting point. Isn't that amazing? All right. So now, beautiful, beautiful. That's lovely. So at this point, who can tell me the next thing we need to do? What do we do here? Now that we've taken the first plastic object to the blue box, what do we now do? Do we just go straight to pick another one without dropping it? No, we have to drop it right into the blue box. So how do we do that? We go to magnets, then want to energize magnets. Now, when you click this drop down over here, now you select drop. That way, the robot leaves it in the blue box. And now we are ready to go grab a second plastic object, which is blue in color, the next blue dot. Okay, now, but before we start moving, we need to turn another 180 degrees. So we go to drivetrain, and then we want to turn right 180 degrees. Okay, and after that, we want to move forward. Okay, so now, how much distance do we need to move in order to get to this, right, this spot exactly? Remember, the last time it was supposed to be 800 millimeters because each of the closest nearest intersection is 200 millimeters, and there are 4 intersections. So when you multiply 200 by 4, it gives you 800. However, when we do exactly that, we find out that our yellow tip, which is basically what the robot uses to pick up the object, actually kind of moves a little beyond the location of the dot. That was why we had to subtract from it. We subtracted 75 mm. Okay, so now what distance do you think we can move to get exactly to this blue object here? What distance do we need to move? Anybody? Anybody? Okay, someone is saying 925, 925 mm. Okay, does any other person have a slightly different answer? Does someone have a different answer? Okay, someone is saying 1125 mm. Okay, 1125. All right. Okay, that's actually interesting. As a matter of fact, 1125 is correct. That's the correct distance you need to move. Now let's look at it together. So when I do drive forward for 1125, and then I kind of restart, then let's see what happens. So it picks the first one, goes back, drops it, turns around, goes exactly at the position of the next one. That's amazing. Okay, now what next do we do? Who can tell me what we need to do next? What do we do just before we pick? Any idea? Energize magnets, exactly. So we need to energize magnet actually. So we go to, as we are here, we go to magnets, then we drag and drop energize magnet to boost, and then we go to drivetrain, we want to turn right for 180 degrees, and then we have to move forward for exactly 1125. That will take it straight to the starting point. That is the blue box right there. Okay. Now, having done that, we have to go to magnet again. We want to energize magnet to drop, and then we want to turn again. We want to turn another 180 degrees to the right. 180. And then when we click the restarts, then you can see that it goes, picks it up, turns, drops that, goes back, picks up the second one, turns, drops it, right? And then it's ready to make the next movement to the last blue plastic container, right? So how many of you are able to get the code? How many of you are able to get the code? How many of you have been able to follow me up to this point? You're able to get the perfect code and your own works excellently. Beautiful. So I can see Chukwemeka, I can see Jane. That's lovely. That's lovely. That's lovely. Okay. Beautiful. Beautiful. All right. Cheesy. Cheesy, are you following us? Yeah, I believe Cheesy is following us. But she answered the last question correctly. Emmanuel also answered the last question correctly. Okay, Sunday, beautiful. Cheesy, are you with us? Oh, okay, lovely. All right, Cheesy has answered. Okay, beautiful. Okay, so now, how much distance do you think we need to move? How much distance do you think we need to move in order to get to this spot? What distance do we need to move? So I want someone to answer using the same logic. All right. So who is answering? Okay, so I can see 1,525, 1,525. Okay. If you answered 1,525, you actually answered, but let me see more answers. 1,525. Are you sure? Think about it very well before you tell me the answer. 1,525. Okay. All right. Okay. 1,525, 15. Okay, someone is saying 2,225, 2,225. Are you sure? Okay. So now let's see. Let's enter 1,525. So now we've turned right. We can use drive forward for 1,525. And then we restart and then we move forward. It picks the first one, drops it, goes back, picks the second one, drops it, goes back, and then it gets to the last one. So that means 1,525 is the right distance to move. So now we've gotten there. We use our magnet again to pick it up. Then we are going to turn right for 180 degrees. and then we move all the way back, which means we have to move another 1,525 millimeters. And when we get there, we need to drop. So we go to magnet, energize magnet to drop. And just like that, we are there. So we have to turn right for 180 degrees. So look at that. So now let's run the program and see the robot pick up all the blue plastic dots, and here we go. So it picks the first one, turns around, drops it, goes back, picks the second one, turns around, drops it, goes all the way to the last one, picks it, turns around, and drops it. Whoa, isn't that amazing? That's lovely. Okay, now, beautiful, beautiful. Okay, so now the next thing we have to do is, so how many of you were able to write the code correctly? How many of you were able to write the code correctly? Okay, I can see your hand. Sunday. All right. Lovely, lovely, lovely. Okay. That's really amazing. That's really amazing. All right. Okay. So now let's look at ways we can make this code shorter. Now, do you believe we can make the code shorter? That's the optimization we mentioned. Now, do you think we can make the code shorter? Is it possible? Is it possible to make it a little bit shorter than this? Is it possible? Okay, so how many of you are excited to see us make the code shorter? Okay, that's lovely. All right, so look at what programmers do. Look at what programmers do, right? So experienced programmers, when they have a long code, all right, and they want to optimize the code, all right? I remember I mentioned optimization, that we'll be looking at how to make optimizations, all right? So now, the idea is to make your code look shorter and more interesting, all right? So when it looks shorter, it becomes more interesting, okay? So now, looking at this code looks long and kind of boring, all right? So we want to optimize the code, want to make it shorter and use the same code to pick up the other dots, the red glass waste. We are going to use it to pick them up, and the green biodegradable waste will also pick them up and return them to their. Okay, so how are we going to do that? So what we do is, looking at this, what we need to do first is we look out for patterns. Okay, we look out for pattern. What do I mean by pattern? So we look out for similarities. Okay, similarities. Now, what are the similar things we can see in this long code? Now we are seeing something that looks like patterns. So the first pattern here is, everywhere we are moving forward a certain distance, right? We are always moving forward. We are never moving backwards or reverse. So that's one. Then at some point, we are always energizing the magnet to boost, right? That's another pattern. Then every point in the code, whenever we want to turn, we are always turning 180 degrees. Every point. We never turned 90 or maybe 100. No, it is always 180 degrees. So these details will help us in our optimization. Now, the next thing is we are energizing the robot to drop, right? So now what it means is that we can divide this code into smaller chunks. So I'm going to close this playground for a moment. I'll open it back. All right. But I just want to show us something. Now we can divide this code into smaller chunks. Now look at this. Now, if I cut this code at exactly this point, and then if I cut it at exactly this point, sorry, not that point. If I cut it right here and cut this one right here, you will see that these three codes look alike to some extent, right? So what do I mean? Can someone see my screen clearly? Can someone see my screen? Yes. So I want to show you how you can make your code look shorter, all right? So now when you look at these three codes, they have some sort of resemblance. So let's look at them together. Now, apart from this when started, all right? So I can just keep this when started separate. So apart from this, now all three code look alike, okay? Here we drive forward. In the first one, we drive forward, we energize magnets, we turn right, drive forward, energize magnets, turn right. Now look at this one. Drive forward, energize magnets, turn right, drive forward, energize magnets, turn right. And the same thing applies for the last one. The only difference is that in this first one, we are moving 725 meters all the time we want to move forward. Is always 725 meters. In this second one, the distance changes to 1,125 meters. In this last one, the distance equally changes to 1,525 meters. All right. So you can see that the code looks exactly the same. The only difference there is their what? Distance. Now, when I do, as a matter of fact, 1125, when I subtract 725 from 1125, that gives us 400. All right. Now, when I subtract 1525, when I subtract 1125 from what? 1,525, it gives us 400. So basically, the distances that were moved in this first one, all right, when you add 400 to it, it gives you the distance in this, and then when you add 400, it gives you the distance in this. Is that correct? I mean, if you are seeing what I'm saying. Okay, someone is saying, excuse me, sir, I don't understand. Okay. Okay, someone is saying, I don't understand. All right, I'll try explaining again. So I was saying that all three codes look similar. All right, all the three codes look similar. All right, so we are looking at how to optimize the code. In other words, how to make the code shorter. So this was the initial first code that we had, all of them together, but I had to break them into three parts at some point. So I want to get just one single code that can do this, that can contain all three, but in a shorter and more compact way. Now look at what I'm going to do. Now I can go to my logic. Now, if I get this when started block, all right, now I can use a block called repeats. Look at this. I can use a block called repeat. So I want to write something inside here and repeat it 3 times. Are we following? I want to write something and repeat it 3 times because basically this is a first step, this is a second step, and this is a third step. So when it repeats 3 times, right? So I should have my final action. So repeating is a very good way of making long codes what? Short, right? Now I need to change this 10 to what? 3 because I want to repeat. But then there is a problem. How do I handle the distances, seeing that the distance is always changing, right, by 400? So what do? I have to make a variable. Since distance varies, a good way of storing a data that varies, storing data that varies is through what? Variables. I mean, it's even in the name, variable. So how do I do that? I go to logic Then I scroll down. I should find make a variable. Okay. I want to make a variable. I click make a variable and I want to call it distance. Oh, okay. It says distance is a reserved word. So I can use distance with an underscore and I submit. So I have my distance here. So I called it distance underscore, okay, with an underscore to make it different. All right. So here is what I'm going to do. I'm going to write, I'm going to make a single code that hello. Okay, can you hear me? Please do not mute me. Please do not do that, please. Okay, let's continue. All right, so here's what I'm going to do. I'll have to replicate this code exactly. All right. Now, if I duplicate this and place it right here, all right. Now, the next thing I'm going to do is I have to, instead of having this, I can use a distance variable by saying, instead of having just this can still be here, right? I can use a value here. I can place this right here. Okay. In fact, I can put this here. All right. So look at that. Can you see that? So I can put this right here. Okay. Now, our initial value of distance should be 725. Okay. Someone is raising. Oh, you can't see my screen. Oh, okay. I'm sorry about that. I'll reshare my screen. How about now? Can you see my screen? Okay. So I hope I've not moved so far. Okay. You still can't see my screen. Can you see my screen now? Okay, good. All right, good. Okay, so I'm going to discard all of this and then I'll just run through that again. All right. So now remember, previously all these blocks were this way. This is the code that allows us to pick up all the blue dots, and not just that, take them, each of them, to the what? To the blue box, right? So I was trying to show you something, that when you break the code at this spot, you will find out that basically you have three codes that look exactly the same, only that the distances vary, right? And to get the next distance, you add 400. So basically, this is 725, 725. When you add 400, you have 1125, 1125. You add 400, you have 1525. That way. So the difference is what? 400, right? Now I'm trying to make just one code. I want to make just one code, right? That will be shorter, right? And then with that one code, the robot can be able to carry out the same exact task that these long three codes actually performs. Okay. So what do I do? Now I will go to logic, scroll down, get my when started. Okay. Now I have to repeat something 3 times. So I have to get my repeat block. This is my repeat block right here. I put it right. Here. Now instead of 10, I should have 3. Why? Because there are 3 parts here. All right, are we still there? Are we together? Can we continue? Okay. All right. So now we want to repeat 3 times. Okay. So now what we do is we want to copy this duplicates. That way we have all of this. So basically we put this right here. And when we've done that, we scroll down and find our variable block. We want to make a variable called distance. Now drag this set distance to something. So I want to place my set distance right here. And it's going to have a value of, or rather, I want to put it right here. So this one has to be here, right? So initially, I can call my distance 0. Okay, so initial distance is 0. Okay, now I can change, instead of set distance, I can put change distance, right? I can put change distance by something. So I put change distance right here. Then here I want to type in 400. All right, are we there? So basically, distance is initially 0. In the next step, okay, so to duplicate, what you need to do, you click where you want to duplicate from. You click where you want to, for example, here, you right click, then you see a list of options. So select duplicate, that way you duplicate, right? Okay, so now that I have this, I'm going to take my distance block and place it right here, right? And again, I'll also place distance right here. Can you see that? So basically, can you see that? Exactly. So now, initially, distance is 0. Okay, someone is asking, you press and hold the button and then some options show. Yes. So all you need to do is just press. You necessarily don't need to press and hold, right? So you can press and hold, it can work. But once you take your cursor to the spot where you want to duplicate from, you just click the right button and then you see some options. When you select duplicate, it duplicates the block. Okay, so now we have this. So initial value, our distance is going to be 0, right? So after that, the distance becomes 400 and it does all of this. Now we need to change distance again. Okay, so let's look at that carefully. So after the robot is able to cover this entire distance, so we need to change it for it to be just before it starts the next step. Anyway, that's okay. It should work totally fine. So now we can discard this block and discard all of this, and so I want to delete that. Okay, so now let's open the playground once again and let's click. You can see our code. So now let's try running the code. Now I can see that this code looks shorter, doesn't it? I hope it does. It looks shorter. Okay, now when I click play, let's see, it moves. Whoa, it goes. I see. Something is not right. So I'm going to stop this. Now, initial value of my distance. I should start with, how do we fix it? I can place this here. Let's just start with a distance of We'll start with a distance of 725. Yeah. So we'll start with that, should be the starting value 725. All right. So here we should have set distance to 725. 725. Okay. Then we have to place this right here. Right. Then at the end, we can change the distance by perfect. So this should work perfectly. So now let's make these few modifications and then run the code. When I run, it goes straight, picks the object, comes back, then it goes all the way to the next one, picks it, turns around, comes back, drops it. It goes all the way to the final one, picks it, turns around, and drops it. Can you see that? Isn't that interesting? So this way, we've been able to shorten the code that was long, and now we have it in a version that is more concise and easier to write. So this is what we call optimization. So how many of you were able to do this? Okay, beautiful. And your code works perfectly, right? Okay, Jane, I can see that. That's lovely. That's lovely. That's lovely. All right. So now the next thing we need to do is we need to move over to the red box, and then we collect all the red glasses. All right. So we collect the red object. So now, how many distance do I need to? What distance do I need to turn in order to move to the red box? What direction do I need to turn? Who can tell me what direction I need to turn? 90. Yes. Now, do we turn right or left? Exactly. Jane, you've answered correctly. So we turn 90 to the left, right? So I'll stop this for a while. Now, I'm going to go to my drivetrain. I want to turn right for 90 degrees. Okay. Turn right. When I place this right here, okay. Now, when I hit play, oh, it starts all over again. So I will restart this. So at this point, it turns right 90 degrees. And then what distance do I need to move? I need to move exactly how many distance to get to this spot? How many distance? How many millimeters? Who can tell me? Anybody? $800, Bamiche, that's correct. So I turn right and then I want to drive forward for 800 millimeters. 800 millimeters. Beautiful. And then I have to turn left for 90 degrees so that it aligns. Okay. All right. So now, then someone is saying it is not big. Don't worry, 800 works perfectly fine. All right. So now I can duplicate this. All right. Then did you see where I duplicated from? I have to separate this and duplicate. Then I can place this right here. So that way it not only picks all the blue dots, it goes to the red side and then it picks all. Okay. So now do you understand this? Are we good on? Oh, okay. Sunday. What's the challenge? What was the challenge? It is not big. What do you mean by it is not big? I don't really understand that. You can unmute your mic and speak up. Sunday, you can unmute your mic and speak up. Can you? Okay. So let's just continue. Now, when I run this code, it goes. So let's see if it's going to go to the red box and then to the red dots in order to pick the red dots right after picking all the blue dots and returning them to their blue box. Okay, so it's almost done. Now what happens? All right. It goes there. Whoa. Oh, that means something is definitely wrong somewhere. Oh, I see. I see. Okay, what it means is that we need to, at this point, we need to set the distance. So we have to duplicate this, right? We need to set the distance here. We need to set distance to 725. Now, when we run again, let's see what happens. So it picks, drops, then goes back to the top, picks it, turns around, drops, goes, picks it, turns around, drops it. Now let's see. It goes there, then picks it, drops, it goes there, picks it. Wow, this is really amazing. Pick that, and it equally drops it. Now look at that. Isn't that interesting? Okay. So how many of us are able to follow up to this point? How many of us followed up to this point? Okay, Kechuku, Bamishe, that's lovely. All right, so I want to have Bamishe share her screen. Bamishe, can you share your screen? Please share your screen. I would like to see your work. Hello, are you ready now? Okay, so while we're waiting for Bamishe, can we have someone else share her screen? Okay, Jen says she's behind. Okay, all right. Bamishe is sharing her screen. That's good. All right, that's interesting. Okay. Oh, I see that. That's lovely. Okay, so it goes, it picks the next and drops it. That's lovely. It goes, picks the next, the last one for the blue, and drops it. That's lovely. It goes to the red side, picks it, drops, goes there, picks it, drops, goes all the way to the top, picks the last red material, drops it. That is really, really impressive. Please, let's put our hands together for Bamishe. Let's put our hands together for Bamishe. Well done. Well done. That's lovely. That's lovely. That's lovely. I really love that. Come on, put your hands together for her. Okay. So can I have another person show me what you've done so far? Okay, so go ahead and share your screen. Come see. Kamsi, you can share your screen now. Sunday, is anything a problem? Sunday, are you clear on anything? Do you need clarification on anything? Okay, can we have the next thing? Oh, Kamsi said, oh, your is not working properly. Oh, I'm really sorry about that. But did you write the code? Did you write the code exactly as it is? Are you sure you're not missing out on anything? Kamsi, you said your code is not working correctly. Are you sure you are not missing out on anything? Okay. Kamsi, you can look at mine. You can look at mine and try to fix yours. If you want me to scroll, I can scroll so that you can fix yours or you can cross-check yours. Oh, okay. Like I said, Kamsi, you can look at my code. If you want me to scroll, I can scroll so that you can cross-check yours. Oh, okay. Jane, you can share your screen. So while Jane is sharing her screen, can I have Sunday? Sunday, you need clarification. Where do you need clarification?
Sir,
Oh, all right. I can hear you.
um, I figured out the code and I fixed it, but when he landed at the end, like when he reaches to the end of the barrier, it just flew out. I have to reset everything.
Oh,
How do you stop that?
when it gets to the end of the barrier, it did what?
Like, he just went past it. Like it's outside the barrier right now.
Oh, so that means there is something wrong with a block of code. So all you need to do, just go through the code, go through mine, and try to make sure it's exactly, and try to make sure that yours is exactly how mine is.
Uh,
All right, if you want me to scroll up or scroll down, I will do that so that you can fix your code. Jane, you are saying it's not working. Oh, I'm sorry that it's not working, but what could be wrong? At the red part, Jane, check to see that you have this right here. You have the set distance to 725 just before the second repeat block. You can see here, I have set distance to 725 just before the second repeat block. Okay, so now the next thing we have to do is we another, we duplicate this again, right, from the set distance to 725 and we place it right here. So this way is going to, but before we do that, please remember to turn right. In fact, I'm going to duplicate right from here. So when I duplicate all, I can put it right here. So that way, when I restart and run my code, it can pick up all the materials is expected to pick up. So look at how mine works. You can see it. So it's currently in the blue stage. So once it's done, it should turn and move to the red and start picking up the red box, the red dots. And after the red, it should go to the green section and do the same for the green. Now it's done. Picks that, places it. It picks that and drops it. Whoa, look at that. Isn't that amazing? So is there any Sunday, do you have any question? Sunday, do you have any? Can you unmute your mic and speak? Let me know what the problem is with you. Your hand is raised up. Sunday, but if you keep raising your hand up without saying anything I can understand, I won't be able to help you. Okay. Oh, all right. I think we can proceed. So we can change the view. Let's try going over this again, but with a slightly with a different view. So you can see that robot goes, picks that up, goes back, drops it. It goes, picks the last one, the blue category, drops it. Now, let me also change to a different view. All right. Wow, now that's beautiful. So how many of you were able to get all of that? Okay, Amanda, I can see your hand. That's beautiful. How many of us were able to get all of that? Okay, Cheesy, Claire, that's great. Jane, why is it not working? Jane, why is it not working? I'm thinking there is something you probably missed in the code.
You went a little fast at the red part.
Oh, sorry about that. Okay, so I'll scroll a bit to the red part. So this is it. So make sure the distance you use is exactly the same as mine. So I'll try to zoom in a little bit so that you see it clearly. Oh, is the same. Okay, can you share your code? Let's look at it. Someone else said mine is malfunctioning. Why is it malfunctioning? Hmm, I see. Hmm, oh, okay. All right. So I see. So what we are going to do is I'm going to I'm going to send the code to you. Um, the values that you used somewhere at some point, I couldn't read clearly because your screen size was very small. So I guess a number you used at some point doesn't match. That's why. But your screen size was it was small. It was so small that I could not see your code clearly. Oh, okay. I think I can see. Okay, I can see it clearly now. Could you please scroll up? Okay, so initially you had, okay, 3 distance. Okay. All right. Please hold on. All right. Scroll down. It's okay. It's okay. Please hold on.
So I might leave in 1 minute, and if I'm going out in 1 minute.
Oh, okay. All right. Jane, I can see what you didn't do quite correctly there. Just before the last repeat block. Yeah, so there should be turn right for 90 degrees. Hello, can you hear me? Hello, can you hear me? Just before the last repeat block. All right. Yeah. So just before the last repeat block, where you have set distance to 725, there should be turn right for 90 degrees, then followed by drive forward for 800 millimeters and turn left for 90 degrees. Okay. Try running the code again. Let's see. I see. Oh, I see. So stop. Stop. Can you stop now? Okay, so let me see the code. Go to the second repeat. Go to the second repeat. The second one. Is that it? Scroll down. Scroll up. Scroll up. Keep scrolling up. Okay, now scroll down. Stop. So I see where the problem is coming from now, Jane. I see where the problem is coming from now. Just before, can you scroll a little bit up? Just before the second repeat block. Yeah, so you had scroll up, enough. It's okay. So you have turn right for 90 degrees, drive forward for 800 mm. Now the second one should be turn left for 90 degrees. Exactly. So ensure it is that way. Scroll down. Yeah, that should be left also. Scroll down. Yeah, that's all. So now run the code, restart and run the code. It should work now. Okay. So who else has a challenge? If yours is not working well, you may as well let me know so that we fix it together. Oh, I see. Something is still not quite right. Okay. Hold on. Can you stop now? Stop the code now. Stop. Drag it to the, yeah. Okay, so go to the second repeat block. I want to see your second repeat block clearly. Okay, so you have drive forward, energize magnet, turn right 180. I think I can see where you missed it. So listen to me clearly. So the first block should be under the second repeat section. The first block should be drive forward for distance millimeters. The second one, energize magnet to boost. The third one, turn right for 180 degrees. The fourth one, drive forward for distance millimeters. The fifth one, energize magnet to drop. The sixth one should be turn right for 180 degrees. The sixth one should be turn right for 180 degrees. So remove that, drive forward for distance, whatever. Yes. And the last one should be change distance. Hold on, hold on, hold on, hold on. Scroll down. Scroll down. Scroll up, rather. Go to the second repeat block. Second repeat block. Yes, stop. Stop. Yes. Scroll down a little bit. Stop. Between the energized magnets to drop and change distance by 400, right? There shouldn't be any drive forward for distance There shouldn't be. It should only be turn right for 180 degrees and change distance for 400. So remove the drive forward for this. It shouldn't be there. Now scroll down to the last. Scroll down. So for that last part now, so you should have. So for that last part, you shouldn't have drive forward for distance. So just remove it. Now run the code. It should work now. Okay. So if you haven't, if anyone else has probably your own is not working perfectly, you can as well let me know so we can fix it together. Nah, it's okay. That's perfect. I can't see your screen. Okay. So okay, I guess it's working perfectly now. So does anyone have is there any other person whose code is not working correctly? So we fix it. Okay. Anyone? All right. So I guess we are all good. So now I've showed you how to save your work. So again, I would like you to save this. So for those that don't know how to save their work properly, so all you need to do is you have to pay attention. Now click File. Can we see my screen? Hope you can see my screen clearly. Can we? Can we all see my screen? Okay, good. Kamsi, by the way, is your code working now? Kamsi, is your code working now? Okay. Okay, I guess Kamsi's code is working. Sunday, is your code working? What's the challenge? Okay, so let's save. So here is how to save. Click File. Now you want to click Save. All right. Now automatically it will bring up your. I'm going to share my full screen so that you will see. So that you see what. I'll stop sharing so I can share my screen, my full screen. So when I click Save, it brings up my file explorer, right? All right. So now I'll select the folder where I want it to be saved. So I go to desktop, then I choose the folder which I created the last time called Sysmo Bootcamp. So I open it, then there I can still see the code I wrote earlier in the last class, which was our first virtual robot coral reef cleanup. So now I'll call this one. You can save it as whatever you want. I'll call this one uh it just went away. So I'll try that again. Save. Was malfunctioning? Was malfunctioning?